I would be old and gray before we got back to video land. I'm so excited to get back into the swing of things with our math videos. We are getting into lesson 10 right now. We're still in module 5. We just finished our celebration of learning, and I think you guys did a terrific job, especially considering that we just finished lots and lots of testing. So we are going to be working with a method that we're going to call the tiling method, and we're going to be doing some exploration of areas of rectangles, and we're going to be multiplying whole numbers by fractions. We're going to use the tiling method in lesson 10, but please know as we move forward, we're going to be leaning toward the standard algorithm. It's typical Eureka fashion. We're going to use some pictorials and some modeling early, and then we'll start working towards the traditional algorithm. The reason why we're doing this is so that area really has a deeper meaning for you. We're going to see, what does area actually mean? Well, it actually means how many squares can you fit inside of a rectangular shape, and we're going to use those squares in lesson 10 as tiles. We're going to refer to those squares as tiles, and we're going to be looking at the tiling method. So I think you guys will enjoy it. We're going to get into a few examples right now, and then we'll work on this some more tomorrow in class. And tomorrow happens to be Friday, so that's a wonderful thing. Okay, here we go, guys. Again, this is lesson 10, and this is very thin. This is that new and improved program we are going to be using for our videos now, and I hope that I've figured out all the glitches. So we're in lesson 10, we're in module 5, and we're going to be using, like I said, a tiling method to investigate the area of some rectangles. So let's just start off with some pretty straightforward numbers. Let's look at a rectangle that would have the dimensions of 2 by 3. So we're going to draw that rectangle here, and it's going to be 3 wide and 2 tall. Okay, so now we're actually going to draw the tiles or the squares that would fill this rectangle. So as you can see, and I'm going to try to be very precise, but I'm still working on it here. So you can see this is 1, 2, 3 tiles wide, and then this rectangle is 1, 2, 3 tiles tall. So with that, we have 1 tile here, 1 tile here, 1 tile here, 1 tile here, and 1 tile here. We're using this tiling method to figure out 2 times 3. I know you guys know what 2 times 3 is. I hope so, at least by this point. But we're going to I'm just using this very simple first example to show you how this tiling method works. So we have this rectangle set up. It's 3 wide and 2 high, excuse me. And now we're just going to go through and multiply. So we have 1 times 1. Well, that's 1. And then we have 1 times 1 again. That product is 1. We're going to go through here, and we're going to find that the products within each tile are 1, because you guys know 1 times 1 is 1. So we've done that. Now we have to figure out, okay, well, what do we have inside this rectangle? We have 1, 2, 3, 4, 5, 6. According to our tiling method, the area of this rectangle is 6, or 6 units squared. Ooh, I think I'm going to like this new program. I think this is going to work out well. Okay, so according to our tiling method, the area of this rectangle is 6 units squared, and according to just our very basic understanding of multiplication, which we established probably in 2nd or 3rd grade, 2 times 3 is 6. So that totally checks out. That is great news. Let's make our example just a little bit more complicated. The purpose of this tiling method is for us to use the standard algorithm to multiply mixed numbers and multiply mixed numbers with whole numbers. So now let's, instead of doing 2 times 3, let's do 2.5 times 3. And again, let's use the tiling method. So we're going to draw a rectangle. Of course, these are not proportional and not so straight, if I might add. Oops, I forgot to fill this in over here. Let's fill in the notes here. So rectangle D is 3 units long, and 2 units wide. Sorry, you know, I was using more volume language up here. We should be using length times width. I have to go back into two-dimensional land. So this rectangle is 3 units long, length, and it's 2 units wide. I'm sorry that I was using kind of volume language when I started talking about that. We are back in two-dimensional flat land here, Mrs. Calamaris. Okay, so 3 units long, 2 units wide, and the area, as you guys know, is 6 units squared. Okay, so let's look up here. So what we're actually doing is we're just creating our own examples, and I want these examples to be a little bit more complicated than 2 times 3 because you guys know 2 times 3. So let's look at 2.5 times 3. Let's make this rectangle 3 units. Oh gosh, sorry, that's not a straight line at all. Sorry, I'm working on it, guys. Let's make this rectangle 3 units long, and then let's make it 2.5 units wide. So that's 1 unit, 2 units. Actually, we'll say 1 unit, 2 units, and then this is our half. And then let's label our rectangle. So we have a fancy one. So we have 1, 2.5. This rectangle is 2.5 units wide, and then it is 1, 2, 3 units long. So we're looking at 2.5 times 3. So we have 1, 2.5 units wide, and then we're multiplying 2.5 by 3, so we have 1, 2, 3 units long. And now that we've set up our tiles, our wobbly tiles, we're just going to multiply and put our products inside each tile. So 1 times 1/2. 1 times 1/2 is 1/2. 1 times 1 is 1. 1 times 1 is 1. 1, so we're multiplying 1 times 1/2. That is 1/2. And then when we multiply, we'll do 1 times 1 is 1. We're putting the products inside the tiles. 1 times 1 is 1. Down here again, we have 1 times 1/2. 1 times 1/2 is 1/2. 1 times 1 is 1. 1 times 1 is 1. Okay, so we've done our multiplying. This is a little bit more complicated because now we have fractions, but we're not afraid of fractions. Now we have to figure out, what do we have? What is our area? What value do we have inside of our rectangle? We'll just count that up. Let's count our ones first. We have 1, 2, 3, 4, 5, 6 ones. And we have 1, 2, 3 halves. Well, we know that 2 halves, 2 halves is equal to 1 whole. It's just a fancy version of 1 whole. So we're going to cash those 2 halves in for 1. And then we have 1/2 left over. So what we have inside of this rectangle, we have 6 plus 1. We can simplify that to 7. And 1/2. 2.5 times 3 is 7 1/2 units squared. I'm running out of room, so I'll just use this unit squared. The area of this rectangle, as we just used the tiling method to calculate, is 7 1/2 units squared. I hope this is making some sense. I know this looks a little different, and please know we are going to work on it tomorrow. But let's check out a couple of more examples here, guys. Okay, kiddos, we are going to look at another rectangle here. Let's look at rectangle B. As you can see here, we are already given a rectangle with the dimensions provided, and now we are going to have to consider what the area is. We're still using the tiling method here. So let's first figure out what is the expression that we can derive from this rectangle. So I see our dimensions. We have 2 1/4. And we have 4 units. So let's look at our expression first. So we have 2 1/4 times 4. So that is the expression that we can derive from this particular rectangle. Let's go ahead and fill in the information here in the space provided. So this particular rectangle is 2 1/4 units long, and it is also 4 units wide. So in order to find the area, you guys know that area is equal to length times width. This is actually less complicated than volume. Volume is equal to length times width times height. Volume is that 3-dimensional measurement that we've been working with a ton. And area is a little less complex. It's a 2-dimensional measurement. And we're kind of going backwards, but we're going backwards because we're going to be focusing our work here on mixed numbers and multiplying mixed numbers together with whole numbers. So you guys are well prepared for this study of area because we've actually have been working with area a lot within our volume studies. You guys know that area is that base layer, and then we've been adding on I guess slices of pound cake or slices of layer cake or slices of bread when we add that third dimension. So life is simple right now. We're just checking out area. I just want you guys to remind yourselves that area is a 2-dimensional measurement where volume is a 3-dimensional measurement. So that's why we have that floaty 2 that refers that you guys know that that floaty 2 is called an exponent. We studied that extensively in module 1. This floaty 2 stands for 2 dimensions because that's exactly what we're doing here. We're multiplying 2 dimensions together. So the result is units squared or units 2 floaty number. Is that making sense? Okay, good. So let's look at this tiling method for 2 1/4 times 4. So this rectangle is all filled out for us. How kind, Eureka. Thank you, thank you. So we have 2 1/4 is comprised of 2 whole numbers, and then 1/4. And then 4 is comprised of 1, 2, 3, 4 whole numbers. We are going to use this model, this space inside our rectangle, to figure out what in the world is 2 1/4 times 4. We are going to do that by labeling just a little bit more extensively this particular rectangle. So 2 consists of 1, 2 whole numbers and a fourth, and then 4 consists of 1, 2, 3, 4 whole numbers. So let's multiply. We are first going to multiply within this tile. So it's 1 times 1, which is 1. And then we're going to multiply 1 times 1, which is 1. For this third piece, we're going to multiply 1 times 1/4. We are going to multiply for this third piece 1 times 1/4. Or we are looking for 1 of 1/4. We've done a lot of work with that. 1 times 1/4. Let's think about that. Upstairs, what do we have? 1. Downstairs, what do we have? 4. 1 times 1/4 is 1/4. You guys should be very comfortable with that because you guys know 1 times any number is going to result in that any number. This is one copy of 1/4. So what our result is 1/4. Okay, cool. So we're going to go through and continue the rest of this multiplication. We have 1 times 1 is 1. This isn't super exciting or shocking, hopefully, to any of you. 1 times 1/4 is, again, 1/4. 1 times 1 is 1. 1 times 1 is 1. 1 times 1/4, Kendi, thank you, 1/4. Let's continue this final row, and we have 1, 1, and 1/4. Okay, so we've done all of that multiplication. I hope no one hurt themselves in the process. Now we have to consider what is the area of this rectangle. Well, we just have to figure out what's going on the inside. Let's count our whole numbers first. We have 1, 2, 3, 4, 5, 6, 7, 8 whole numbers. And then we have 1, 2, 3, 4 fourths. We have 4 fourths. 4 fourths is a fancy name for whole number 1. So what we have is 8 plus 1. 8 plus 1 is 9. So 2 1/4 times 4 is equal to 9 units squared. Secret word is squared. Not cubed, squared. We are now in squared land because we're working with area. I think you guys are great. I'm looking forward to a wonderful Friday with you all tomorrow. We will work on this tiling method. We will work on multiplying mixed numbers by whole numbers. Can't wait. I will see you then. Bye-bye.